Hi and good evening to Madam. So today our group will do a group presentation regarding a topic or a question problem given. So this group presentation is prepared by three members including me. The first member is Isdarwisha, the second member is Natrah, and the third member is me, Jeslyn Nasya. So the problem or the topic that our group has chosen is justify which switch reluctance motor (SRM) is popular in adjustable speed drives. So this presentation is comprised of three parts, which first is the introduction, and it is a brief introduction on adjustable speed drives and also the switch reluctance motor (SRM). And the second part will be on the working principle, and it is the explanation, a brief explanation on the working principles of the switch reluctance motor (SRM). And the third and the last part will be on the justification, which is the part where we state the reason why switch reluctance motor (SRM) is popular in adjustable speed drives. So we will get into the first part of our presentation, which is on the introduction. And before I get into the introduction of our main topic for today, which is on the switch reluctance motor (SRM), I will first do a brief introduction on the adjustable speed drive. So our title on this slide will be the introduction of adjustable speed drive. So an adjustable speed drive is also known as a variable speed drive (AVSD), and it describes the equipment used to control the speed of machinery items. So if the speeds may be selected from several different preset ranges, then the drive is known as an adjustable speed. Whereas if the output speed can be changed without steps over range, then the drive is known as a variable speed. And the adjustable speed drive or the variable speed drive, it may be might be purely mechanical or electromechanical or hydraulic or even electronic. So on this right side of the slide here, we have the schematic diagram of a variable frequency drive, a VFD, which is one of the most common type of VSD. And also we have a diagram of a variable speed drive VSD. So we will get into the next part of our introduction, which is on the introduction of SRM. So what is SRM? SRM is a switch reluctance motor, and it is an electric motor that operates by the reluctance in torque, making it a subgroup in reluctance motors. So unlike any other common brush DC motors, its power can be transmitted to the windings within the stator instead of the rotor. And an alternate name for this switch reluctance motor is also known as the variable reluctance motor (VRM). And usually for a better operation, this motor also uses switching inverter. So this motor, it actually simplifies the mechanical design to restrict the flow of current towards the rotary part. However, at the same time, it also complicates the design because it needs a type of switching system to accompany it in order to transmit the power towards the different windings. So on the right side of the slide here, we have the diagram of the switch reluctance motor. Now we will get into the next part of our presentation, which is on the working principle of the switch reluctance motor (SRM). So the working principle of the switch reluctance motor is it actually works on the principle of variable reluctance, where the magnetic flux of the formation of the rotary magnetic field, it flows through the lowest of the reluctance path. So the rotor will eventually always try to line along the minimum of the reluctance path. And also when supply to say the stator winding is on, thus the stator flux is also produced. And the rotor will position itself, and the stator flux will find the low reluctance path. And this is actually the basis principle of operation of this motor.
Hello, my name is Visha. So I'm going to start with the justification for the reason why switch reluctance motor (SRMs) very popular in adjustable speed drives. So firstly, we have firstly, we have simple structure. Simple structure is basically we are going to talk about no permanent magnets. So why no permanent magnets? Because it contributes to a low rotor inertia and a relatively easy cooling compared to the other motor types. And also, SRM do not rely on the expensive rare earth magnets, and the rotor is made of a ferromagnetic material. The torque is produced by the magnetic reluctance variation as the rotor rotates, and these lack of permanent magnets can contribute to the cost saving and makes SRM less susceptible to fluctuations in magnet price or supply chain issue. And next we have principle of magnetic reluctance. So what is it? Basically, the operation of switch reluctance motor SRM relies on the exploiting the variation in magnetic reluctance within the motor's magnetic circuit to produce torque. And the rotor and stator design are pivotal in enabling the process, contributing to the cost effectiveness and simplicity of the motor. Next, we have high torque density, which is SRMs can achieve high torque density with which is it providing a significant amount of torque per unit volume and or weight. And this characteristic is crucial in application where space and weight constraints are important considerations, such as in electric vehicle or robotics. And next we have ease of control, which is the on or off switching nature of windings allow the straightforward electronic control, and this simplicity of control algorithm makes the SRM attractive for applications that require fast and precise torque control, such as in adjustable speed drive.
So, the second reason why the switch reluctance motor (SRM) is popular is because of the robustness of it in harsh conditions. This could be seen by the three explanations given, which are high thermal tolerance, resistance to dust and contaminants, and tolerant to voltage spike. For the first point would be high thermal tolerance. Because of the absence of windings on the rotor, also the simple construction of the motor helps it to handle high temperatures. SRMs can withstand high temperature without disturbing the performance or longevity. Second point would be resistance to dust and contaminants. SRMs has less intricate designs than other motors, making it more resistant to dust, dirt, and other contaminants. This is very beneficial when the motor is exposed to the environment that could compromise the functionality of the motor. And last point would be tolerant to voltage spikes. The robust design of SRMs make them more resistant to voltage spikes and electrical disturbance. In crucial It is crucial in harsh industrial environments where electrical noise and fluctuations are common.
So next we are going to talk about the cost effectiveness. So firstly we are going to talk about the material cost, which is it's common about the material, which is they are going to use ferromagnetic materials because of both of the rotor and stator. These materials are readily available or cost-effective, contributing to the overall affordability of SRMs, and the absence of expensive permanent magnets such as a rare earth magnets further reduce the material cost. And next, we have minimization of aesthetic materials, which is SRM have a straightforward mechanical structure with a rotor and a stator. So basically, the absence of brushes, permanent magnets, and also the complex control mechanism simplifies the constructions, making them rugged and reliable. And this simplicity often results in cost effectiveness and ease of material. Next, we are going to continue with manufacturing efficiency. So first, it's simple construction because the basic structure includes a stator with the windings and a rotor with a salient poles. This simplicity leads to reduced manufacturing complexity, fewer assembly steps, and also lower the production cost. Next, we have ease of scalability. which is the design of SRM allows the scalability without major modification. Manufacturers can adapt the motor for different power ratings and size without um, significant changes to a manufacturing process. This scalability basically enhance the manufacturing efficiency and flexibility, enabling the production of motor for a variety of applications. And next we have reduce labor and assembly costs. Okay, so this straightforward design of SRM reduce the number of components and the complexity of the assembly. So this result in lower labor costs and quicker assembly times. The absence of brushes and commutators, which require precise alignment during assembly, further contributes to the efficiency of manufacturing process.
So, for the last one on cost effectiveness would be competitive pricing. We could see from the scalability and standardization. As SRM's technology becomes more widely adopted and production volumes increases, economies of scale come into play. Higher production volumes often lead to lower per unit manufacturing costs. Additionally, standardization of components and manufacturing processes can further reduce costs, making SRMs more cost competitive. The other one would be advancement in technology. Ongoing advancement in the design and manufacturing of SRMs contribute to cost reduction. Improved efficiency in production processes, along with innovations in materials and design, can lead to lower overall costs for SRMs. So, from the question justify why switch reluctance motor SRM popular in adjustable speed drives, we could conclude that switch reluctance motor or SRM is popular because of its simple structure, its robustness in harsh conditions, and how SRMs is cost effective. That's all from me and my group mates from Group 1. Thank you.